Hello, and welcome to today's video. Today, we are going to talk about some topics in geometry. Geometry is a fun topic in math where we can draw figures, talk about those figures, and write what we call proofs about those figures. There is so much room to explore, but for today, let's start with the basics. Let's think about some fundamental objects in geometry: points, lines, line segments, and rays. All of the shapes that you typically think about in geometry use these objects. A point is a position in space. To draw a point, we use a little dot and label it with a capital letter, like capital A or capital B. A line is a sequence of points that runs straight, has no curvature, and runs indefinitely in both directions. To illustrate this, we put arrowheads on both ends of the line. If the line passes through, say, point A and point B, then we call this line AB. Notice that we draw a double-headed arrow above the letters AB as a label of the line. Let's talk about line segments now. A line segment is like a line, but it has two endpoints. This line does not go indefinitely in either direction. To label line segments, we look at the labels of the endpoints of the line segment. We would call the line segment below line segment CD. Notice that we draw a straight line with no arrows above the letters CD as a label of the line segment. Now, a ray is also like a line, but has exactly one endpoint. The ray runs away from the endpoint indefinitely. To label rays, we look at the label of the endpoint of the ray, in this case, point E, and the label of one point that the line passes through, in this case, point F. For this example, we say that this ray is ray EF. Notice that we draw a single-headed arrow above the letters EF as a label of the ray. Let's look at two rays that share the same endpoint. An angle is a measurement of the amount of space between the two rays. Let's bring another pair of rays with the same endpoint. Notice that the angle between the two rays on the left is smaller than the angle between the two rays on the right. We don't exactly need to be working with rays. We could also do the same thing with the line segments. The definition for angles stays the same, and all the definitions will remain the same regardless of whether we draw lines or line segments. To name an angle, we first draw an angle symbol. The angle symbol almost looks like a little wedge that is lying on the ground. We then write down three labels: the label of a point on one of the rays, the label of the endpoint shared by both rays, and the label of another point on the other ray. For the two angles we were talking about earlier, we would call the left-hand angle ABC, and the right-hand angle DEF. If you want to measure an angle, you will want to use a measuring device called a protractor. It's kind of like a ruler, but rather than measuring lengths, it measures angles. Protractors measure angles in degrees, kind of like how standard rulers measure lengths in inches. In this video, we won't worry too much about how to use a protractor to measure angles, and we'll instead focus on the different types of angles you can see. When we write down the measurements of an angle, we first write down the letter M, the label of the angle, an equal sign, and the number we measure using the protractor. For example, if we want to talk about the measure of an angle, ABC, over here, then we would write down M angle ABC and an equal sign. Using a protractor, we can see that this angle is 60 degrees, so we'll write down 60 degrees next to the equal sign. In geometry, we categorize angles into different groups. If an angle is less than 90 degrees, like angle ABC, then we call that angle an acute angle. If an angle has 90 degrees, like angle DEF, then we call that angle a right angle. If an angle has between 90 and 180 degrees, like angle GHI, then we call that angle an obtuse angle. If an angle has 180 degrees, like angle JKL, then we call that angle a straight angle. If an angle has greater than 180 degrees, like angle MNO, then we call that angle a reflexive angle. Now that we know a little more about angles, we can talk about parallel and perpendicular lines. We say that two lines are parallel if they will never intersect, meaning they never cross each other. Line AB and line CD here show us what it looks like when two lines are parallel to each other. To write this down, we write the labels for lines AB and CD and put two vertical bars in between the two labels. To make this clear in a diagram, people often draw arrowheads in the middle of both lines. Two lines are perpendicular if the lines form a 90-degree angle, also called a right angle. When they intersect with each other, here we can see that line EF and line GH are perpendicular to each other. To write this down, we write the labels for lines EF and GH and put a perpendicular symbol in between the two labels. The perpendicular symbol looks a bit like an upside-down letter T. Parallel and perpendicular lines will come into play in some of the shapes we are going to talk about right now. A polygon is a closed shape made up of line segments that we call sides. Below, we've drawn some polygons. We say that polygons are closed because there are no openings in the shape. Here are a couple of non-examples of polygons. The left polygon is made of straight line segments, but it's not closed. The right polygon is closed, but notice that part of the shape is drawn with a curved line instead of a straight line. One way to categorize polygons is by counting the number of side lengths. In other words, the number of line segments that make up the polygon. A polygon with 3 side lengths is called a triangle. A polygon with 4 side lengths is called a quadrilateral. A polygon with 5 side lengths is called a pentagon. And we can keep going. This chart shows us the names of polygons with 3 to 10 sides. And there's even more polygons we could draw. However, we are going to focus on only a few of these. Remember, a triangle is a polygon with exactly 3 sides. This is the simplest polygon that you can make. Let's talk about a few ways we can categorize triangles. If a triangle has at least 2 sides that have equal lengths, then the triangle is called an isosceles triangle. A triangle is an equilateral triangle if all 3 sides have equal lengths. A triangle is a scalene triangle if all 3 sides have different lengths. A triangle is called an acute triangle if all 3 of the angles inside the triangle are acute angles. If a triangle has one obtuse angle, then that triangle is called an obtuse triangle. If a triangle has one right angle, then that triangle is called a right triangle. As you can see, there are lots of ways we can categorize triangles. While simply looking, triangles are extremely complex and important. You can even take a class called trigonometry, which is an entire class all about triangles and their properties. A quadrilateral is a polygon with exactly 4 sides. There are a few types of quadrilaterals that we can talk about. A quadrilateral is called a trapezoid if at least one pair of sides are parallel. A quadrilateral is called a parallelogram if 2 pairs of sides are parallel. Notice that by default, all parallelograms are trapezoids. Pause the video and think about why this is. We can also further break down parallelograms into 2 more categories. A parallelogram is called a rectangle if all 4 of its angles are right angles. We can also describe this property by saying that pairs of adjacent sides in a rectangle, meaning the sides that are next to each other are perpendicular to each other. A parallelogram is called a rhombus if all the sides have equal lengths. Let's think about a square. A square has 4 sides, so it's definitely a quadrilateral. How do squares fit into the definitions we just talked about? Well, in a square, we can see that there are 2 pairs of sides that are parallel to each other. The top and bottom sides are parallel to each other, and the left and the right sides are parallel to each other. That means that the square is a parallelogram and also a trapezoid by default. Is a square a rectangle? Well, all 4 angles are right angles, so yep, it's a rectangle. Since a square by definition has 4 equal sides, that makes it a rhombus too. Wow! The square matches every label we talked about for quadrilaterals. What about this polygon? This polygon has exactly 4 sides, so it is a quadrilateral. So, what about the other words we have to describe quadrilaterals? Well, it looks like the top and bottom sides are parallel, and the left and right sides are parallel too. So, we know we definitely have a parallelogram, which also makes it a trapezoid. None of the angles inside the shape are 90 degrees, so we don't have a rectangle. If you were to grab a ruler, you would notice that every side has exactly the same length. So, the shape is a rhombus as well. Calling a shape by many different names can be difficult, but it could be helpful to think of an analogy. How can we categorize poodles? A poodle is a breed of dog, but since a dog is a type of animal, it follows that a poodle is an animal. All animals are living things, so poodles are living things. We're doing the same kind of categorization with polygons. Now, let's move away from polygons and talk about circles. A circle is the set of points that are equidistant from a point that we call the center of the circle. We label a circle by drawing a little circle with a dot in the center and write down the label of the center. For example, we can look at this circle and notice that its center is a point P. Thus, we would label this circle with the circle symbol and the letter P. Every single point along the circle is just as far from the center as any other point on the circle. The radius of a circle is the length of a line segment between a point on the circle and the center of the circle. Regardless of the point you pick on the circle, the radius will remain the same. The smaller the radius, the smaller the circle. The bigger the radius, the larger the circle. The diameter of a circle is the length of a line segment that satisfies two criteria. The endpoints of the line segment are along the circle. The line segment passes through the center of the circle. Look at circle P. Which of the two line segments would give you the length of the diameter of the circle? Well, line segment AB has endpoints that are along the circle, but it does not pass through the center of the circle, so you cannot measure the diameter of the circle with that line. What about line segment CD? Line segment CD has endpoints along the circle, and it passes through the center point P. Thus, you can measure the length of the line segment CD to measure the diameter of the circle. We actually call lines that pass through 2 points of the circle, but not necessarily through the center, such as line segment AB, a secant line. For this diagram, you can also notice that the diameter is always twice the length of the radius. Whew! We talked about a lot of shapes today, and that's just the surface of geometry. Once you have the definitions that we covered in this video down, you will be ready to solve elaborate problems and form mathematical arguments or proofs about these shapes. Thanks for watching, and see you next time.